Hey everyone, welcome back to the C++ Boot Camp. The last time we talked, what did we do? We talked a little bit more about types and converting from characters to integers and why that actually works. We also wrote a program that dealt with the Ascii table. So what I wanted to do was just continue along that same path, but add a bit more detail. Because, let's see, what did excuse me, I wanted to go ahead and do a setup that was a bit more permanent, so I wouldn't have to keep building the project from scratch, even though I will, for the most part, start most of the programming that I do from scratch until we get to the more complicated pieces where it really wouldn't make sense to start from the very beginning, but I'll try to have enough in place that it isn't too much of a waste of time just watching me get set up here. So with fundamental types and programming in general, we've been able to talk a bit about what C++ has to offer in that respect. So we've got the int, the char, the float, /double, and the bool. But we've also introduced the idea of looping, and the tools available to us right now in C++ are the for loop, the while loop, and the do while. So we focused on the for loop before, and we're going to use it again this time, so that we have a little bit more insight into how this works. Another idea that I'd like to leave you with here is the idea of development itself. What this really is a constant cycle of input, processing, output. So any program that you can think of is going to have these components for the most part, unless it doesn't present anything or provide anything to some other component or service in the chain of solutions. So with that in mind, we're going to take these fundamental types and we're going to add another piece to the puzzle. So let's talk about collections of fundamental type collections. Now, you may already know these. You may have already heard of these, fundamental type collections, as arrays. Now, talking about arrays is really talking about memory locations, because the truth is, anytime you define some type that gets used in a function or is passed as a parameter to a function, you're really talking about a memory location. And that is very true with arrays of fundamental types. So we've got int arrays, we've got character arrays, we've got float arrays, etc. And even bool arrays. Okay. So why would you do this? At this point right now, the reason that you would have your arrays of fundamental types is so that you can process things as in groups. So if you're thinking about calculating an average, or if you're thinking about processing a collection of results from Google, or if you're thinking about filtering out images on an Instagram page, I mean, you're talking about groups of things. Now, when you talk about things like groups of entries in a feed, you're really talking about collections of user-defined types, and we haven't gotten there yet. So let's talk about fundamental type collections, and we're going to revisit the Ascii table itself to do a simple example that's going to take advantage of arrays of integers and arrays of characters. So just to refresh your memory, we talked about the Ascii table, and the Ascii table is a fundamental table used for character representations, and it is one of the first things that you come into contact with as a systems level developer. and probably even as a web developer, because you have to think about when you're presenting text on a page or when you're storing text in a file or in a database. You have to have a character representation that's used. And ASCII is limited. It's not Unicode. We'll get to Unicode in a bit, but we're not there yet. So the ASCII table right now is a decimal to character conversion, and you're talking about bytes, where a byte is 8 bits. And the representation that maps the decimal for ASCII to the character for ASCII is built into the runtime of most programming languages, because that is a way, or maybe it's just lookup tables in the operating system. It really just depends. But the idea is almost everything knows about ASCII. But in order to process ASCII, you're usually talking about collections of things. So we're going to do a collection of integers and a collection of characters, and we're going to mimic the ASCII table conversion. So let's go ahead and get started. Now if we go back over here and we have the idea of the ASCII decimal collection, or container, whatever you want to call it, we have to, first of all, the bracket means that you've got a collection, and you have to tell the compiler how big of a block of memory to reserve. And the thing about the array is they're all going to be of the same type. So they're all going to be integers. And then we use an initializer to set each location to 0. Now the second array we need is a character array. And this character array will hold the character collections for each entry in the ASCII decimal collection, to mimic that mapping from one type to the, from one representation to the other. So we're going to do this in 2 pieces. We're going to initialize the ASCII decimal, and then we're going to initialize the ASCII character, so that we've got that grouping, that mapping from one to the other. For this, we're going to use a for loop in both cases because it's the most straightforward. And we're going to use, so the way for loops work, and I might not have explained this before, is you have 3 components. You have the initializer of the iterator, where, let's see, so you say, I have an iterator, and you can define more than one, but usually, I mean, for this, we're just defining one. So we're setting it to 0, and then we have a condition that says what makes the for loop stop. So in this case, as long as it's less than 96, it's going to continue, and then the next piece is the step or iterator component. So starting at 0, less than 96, set I to I plus 1, and keep doing that until the condition is met to stop the loop. And what we want to do here is we want to set the ASCII decimal collection location at the iterator I to I plus 32. And what that will do, it'll start at 0 and go all the way up to 95, and that will give us 32 up to 126. And in this second loop, we're going to do the same thing, but instead of storing the number, we're actually going to store the ASCII character conversion. And instead of storing it in the decimal, we're going to store it in the character, right? So we've got every location is going to be the character cast from the decimal collection location. And if this works like we expect, then you're going to have one array that has all of the decimals from the ASCII table, and in the other array, you're going to have all the actual character representations based on the decimal values in the decimal collection. So we'll set a couple breakpoints, save, we'll do a build. Let's hope it actually compiles, or I have to fix something. All right, now let's go ahead and do the debug. Okay, so we've already initialized these guys and then set the decimal values. So notice that this first thing, what this is the memory location for this collection of integers. And what it shows you after that is all of the values at each location. So if we expand it, you see at location 0, you got decimal 32. And then it's going to keep going until we get to 126, I believe. Yeah, 127, sorry. So now that we've done this first piece, if we hit continue, it's going to fill in the ASCII character collection with all of the character representations of the ASCII values for each location from the decimal array. This is what we had hoped for. And again, notice that this location in memory is not the same as this location in memory. Additionally, when you see me run my debugger, notice that there's a section above the source code and the a watch list or the auto variables. So we'll talk about debugging as we get further along. I don't want to distract with too much information right now, but like I was saying before, with arrays of things, you're talking about blocks of memory, contiguous, consecutive blocks of memory. And every location has its own address in the system. And we'll keep focusing on this as time goes on because memory manipulation, reading and writing from the network, reading and writing from a disk or from some of the operating system data structures and things like that relies on knowledge of the system's storage of things in memory. But, okay, to keep it simple though, what we've done, let me go ahead and stop this, is we have taken advantage of the way the Ascii table works and also started to introduce the idea of arrays of things and use those in for loops to build the ASCII decimal collection array and then the ASCII character collection array to mimic what you see in the Ascii table chart here. I hope that this has been informative, and what we will continue to do in this bootcamp series is add more and more pieces to the use of C++ so that we eventually get to the point where we're writing system level programs, desktop application programs in Windows for this particular series. There'll be other series, but right now we're just Windows and C++. If you like what you've heard or you find it very useful, please like, subscribe, put comments in the comment section. Let me know what I can do better. Let me know what you'd like to hear more about. I really appreciate you guys listening and tuning in, and I'll see you next time.